Hi, I'm Ritik Sharma.
And I'm Parth Wadhavan.
And we have done our project on hydraulic circuits and systems in a tractor. So coming to what is a hydraulic system? Hydraulic systems basically use a fluid to transmit energy from motor to actuator, and it uses the principle that fluids are incompressible and do not have any shape of their own. They generally use in heavy equipment such as tractors, cranes, etc. And the force exerted by the pressurized fluid in a hydraulic system is basically used, and operators can lift heavy loads by using the force depending on how it's applied. Coming to the principles of hydraulic systems, first, the liquids have no shape of their own. Second, liquids for all purposes are incompressible. And third, liquids transmit applied pressure equally in all directions, which is basically the Pascal's law. Parth will take one from here.
Now we'll be talking about the components of a hydraulic system. The major ones are the reservoir, the pump and motor, cylinder, valves, lines and hoses, as well as the hydraulic fluid. Talking about the first thing, which is the reservoir, it is a place wherein the non-pressurized hydraulic fluid is, which is typically the hydraulic oil in case of tractor, is stored. Now, from this reservoir, you need to actually push in this hydraulic fluid so that the eventual cylinder can move. For that, the pump is the thing which actually takes the oil from the reservoir to the control valve, and it is done under high pressure. Now, what provides the energy for this is the motor, and the motor basically is a power source for the pump. And once the motor provides this energy, the fluid is pushed forward, which basically helps in providing the mechanical operations, and this is what in turn lifts the lifting arm, and the final output can be obtained. Now, these are of two types. Firstly is the single acting cylinder, which is depicted over here. But in this cylinder, in this case, the cylinder can only be moved in one direction. And in order to move the cylinder back, we need to provide external mechanical force, which could be done in either form of gravity or spring, which is typically used. But this problem is mitigated in case of a double acting cylinder, which is shown over here. In this case, the movement is allowed in either of the two directions, right? And this is this basically takes away the need for external mechanical force. So this is a better thing to use in case of a tractor system. And then next are the valves. The valves are majorly of two types. One are the direction control valves, which basically ensures that the flow and the path of the fluid which you want is the eventual path and the direction of fluid which you eventually get. These, for example, the check valves allow the fluid to flow in only one direction and doesn't allow the fluids to flow back, which can be problematic. And then there are pressure relief valves. These are valves which help in, which provides a lot of safety value, right? So, for example, they protect the components in case the pressure overloads by providing an outlet for that additional pressure. And the pressure relief valve essentially is like a very important safety component which we always need to ensure that we have. The next are the lines and hoses. Now these lines and hoses are used to connect the different components of a hydraulic system. The lines are typically used for connecting those components which remain stationary while the system is in play. And the hoses are the ones which basically connects the the parts which move relative to each other in a hydraulic system. Now, one thing which you need to take care of, which we have mentioned over here in this note, is firstly, if the hose is too small, the oil flow will be at a very high rate, right? Because of which heat generation will happen, which will mean that the fluid will be losing power. And if the hose is too large, the time and cost of installation can be too high. So we need to hit that sweet spot wherein both of these countering factors can be managed, and we can get an ideal system for this. Lastly is the hydraulic oil. Now, this hydraulic oil is typically petroleum oil refined, which is used in the hydraulic systems. Now, this oil has additives which are put in to prevent rust and minimize frozen. And using incorrect oil can cause harm and basically cause the system to break down, which is of course not favorable. And oil components can also increase and oil, if there are contaminants, it can also increase the operating temperature and damage various components. So we need to very tactically choose the hydraulic oil basis or requirements and the hydraulic system which we have. Ritik is going to take forward from that.
Okay, so let's come to types of hydraulic systems in a tractor. So there are majorly two types of hydraulic systems. One is the open loop hydraulic control system. In an open loop hydraulic control system, the pump inlet and the actuator return ports are connected to a reservoir, and the pump provides a continuous fluid flow in the system. Second is the closed loop hydraulic control system, and in this, the fluid flows from piston pump to a motor and then return to the pump without flowing through the reservoir. The system can operate in either direction. Coming to types of hydraulic controls in a tractor, first is automatic hydraulic control. So this is a type of a feedback mechanism. In this, the output signal is compared with the input signal, and based on the difference between them, the output is changed. And this can be either open loop or closed loop. Second is the automatic position control system. So it is used to position an implement using a hand control lever. So the lever is the one which is in control of the driver, and the implement is the one which is the part of an internal mechanism. Second is the relative positions of the implement and the lever is always the same. So this is the principle that is used in the automatic position control system. So when operated within the maximum pressure limit, the hydraulic cylinder will move the implement to the designated position regardless of any leakages. Third is the automatic draft control system. The hand control lever in the automatic draft control system establishes what draft has to be maintained for the implement. And when the draft is changed, the draft control will automatically raise or lower the draft of the implement depending on what input we have given to this lever. Coming to hydraulic steering system in a tractor. So whenever we have to take a turn in an automobile vehicle, we use a steering wheel. So in the tractor, we use a hydraulic steering system. So in this, we have two different fluids, which are basically represented in the with the different colors. So one is in blue color and one is in the red color. So what happens is when we rotate the steering wheel in any direction, the corresponding fluid flows into the steering cylinder. So what happens in the steering cylinder is that we have a piston which is connected in turn to the pitman shaft. So so we have basically this inlet is for the fluid 1 and this inlet is for the fluid 2. So if we want to move the piston in this direction, we will use this inlet to pump in the fluid. And if we want to move the piston in the opposite direction, which is in the normal direction, then we will push in the fluid from this inlet. So what happens after the fluid is pushed into the cylinder is that this piston has basically two sides. One is the extension on which the pressure is basically applied, and second is a teeth, and which is locked with with another gear, and with this gear is basically connected to the pitman shaft, which basically helps in the rotation of the wheels by rotating the axle. Coming to the work, so the working of hydraulic steering system has been explained in the previous slide. Coming to hydraulic braking system in a tractor. When the brake pedal is pressed in this direction, so this basically this cylinder forces the fluid to flow into the brakes, and this fluid basically transmits the force, and this force, depending on the type of braking system we are using in the tractor, generates the required friction between the shoe and the tire. So there are predominantly two types of hydraulic braking systems in a tractor. One is a drum hydraulic brake and one is the disc hydraulic brake. So something similar happens in the disc hydraulic brake also. When you push the pedal, the fluid in turn transmits the force to the basically brake shoe, and then with the help of the friction, the deceleration takes place. So this has been explained in the previous slide. Parth will take on from here.
Now we're going to talk about the advantages of a hydraulic system. First of all, it's extremely compact. So if you put it in your tractor, it's basically going to be very space efficient. It's powerful because of the energy it can provide. Overloads can be prevented using control valves, which we've already talked about. And the speed change is continuous. And also this can be controlled with the help of a remote, which can have a lot of applications. Now the disadvantages majorly are, firstly, that the pipes are difficult to connect, right? So in case some problem happens, you need a trained mechanics to solve the problem. Leakages of oil can happen, which can lead to undesirable movements, which is of course not needed. The power consumption in such a system can be extremely high sometimes, and that is something which we would not like to have. And the functioning of hydraulic system can often be affected by the external temperature, and that leads to a lot of volatility in the basically the outcome which you are getting, and that is an undesirable place to be. Now, lastly, we'd like to talk about certain challenges and pave a way for research and development which can happen in future. Firstly, we need to understand the growth in science and technology. A lot of agro-based industries have started coming up in various regions which they didn't exist earlier. These regions have the topography which is very different from the ones which we're usually accustomed to. So therefore, the kind of tractors which we need right now should be the ones which are adapted to these different topographies and the different kind of rugged atmospheres which come with it. And at this point, the hydraulic technology is what needs to be at the forefront, because its components are the ones which basically endure the load in driving the crankshaft in order to generate high power consistently. So we need to come up with these components which are rugged enough in order to sustain this high forces which are being applied on them, and a lot of mechanical engineering research can happen in that direction in order to improve the overall tractor systems which we have. With that, we'd like to close this presentation. Thank you.